Hello everyone, I welcome you all in this lecture. So in this lecture we are going to implement the altitude hold controller in a MATLAB and Simulink environment. So like I have already implemented the aircraft pitch control, roll control, yaw rate controller, likewise we will implement. Okay, so already you are familiar with this window, right? So here we will write the necessary parameter which is going to be used in a controller, okay, in a Simulink platform. Okay, here this is a MATLAB script file. Okay, so you are all familiar with this variable, right? So if you don't, you can go back to my aircraft pitch control design lecture. I have explained all these things in a detail. Okay, so when you run this, the required parameter for a altitude hold control design will be saved in a this workspace, right? So it is a good that you saved here and you can utilize this variable directly from here. Okay, this is a route locus plot. You can see the location of route and all, etc. Okay, so already I have explained to you in the aircraft pitch control design lecture. Okay, so now the second window is this I am going to explain in a detail. Okay, so basically, are you familiar with this transfer function? Also, I have already explained to you in aircraft pitch control design. So basically, here you have added one more loop called altitude in the same way what I have explained to you in the theory. Okay. So let's run in the open loop case. First, we need to understand why we need to control the altitude. Okay. So first thing here, let's say for this case, this is called open loop because at the end you are not uh, basically you are not closing the altitude loop. You want to check the open loop response for altitude less in this case by using the pitch. For example, I will give the pitch. Basically I am controlling the pitch here, but I am not taking care of altitude, whether the altitude is hold or not. So let's see what is happening if I am giving the pitch. So basically this is not the open loop in altitude, but basically this you can consider this is a controlling the pitch but not taking care of the altitude. Okay, that means you can go like this, you can go like this. You're not flying like a celestial airplane, that I'm trying to say. Okay, so let's run this. When you run this, are you able to see this altitude plot is going up? You are giving the pitch going up. Let's give the negative. What is the expected result? Go down, right? Pitch down. Okay, this is going down. So one thing is clear, the altitude is not controlled. Okay, now we will control the altitude. Okay, so basically what we will do, we will take a feedback and I will close here. So I have explained to you, right, there in that theory pi block proportional integral. So basically this is p, and with respect to that p, I am taking a 5% of p. So that is combined this pi. Here also pi. Okay, and this is a basically physical limit, position rate limit and position limit. You may put actuator dynamics also in first order. Minus sign also I have explained to you. I do not want to put my gain negative, that is why I put minus sign. Why? Because elevator up is considered to be a negative, but elevate pitch up moment considered to be a, this one pitch up is a positive. So by deflating the negative elevator upward, you are getting the positive moment. That is why I have multiplied by the minus 1 here. I do not want to make my gain is a negative. So one thing is clear, right? So if you have any see, already I explained to you like how to select this block in previous lectures. Like these blocks are already available in the Simulink uh, library, so you can directly take from there and you just type. Okay, like for example, if you want to type, let's say integrator, Okay, so the integrator will come like this. Okay, so already I explained to you these things, and if you have any question, maybe someone you are watching from this lecture, so there is absolutely no problem. You can put the comment in a comment box section, or you can go to back to my previous lecture and see I have explained all those things. Okay, so here I am going to hit those which I have not covered. Okay, so now 100-meter altitude I have commanded, so it is expected that it should control, right? Should be, our altitude should be controlled, right? So let's run. So this is how it is controlled. Okay, and overshoot is very minimal. For example, it is going, even it is not 1 meter, it is going above, right? It is 100.8. So that is how it is controlled. Okay, you can see some kind of may experience the discontinuity, right? That because of the, I mean to say, time step. If you want to go here, modeling, model setting, fixed step you may take. Okay, you may use RK4. Okay, fixed step RK4, and here you can 0.01. Okay, apply, then okay. Okay, when you hit the run button, you see smooth curve, right? That's because of the mistake. Okay, so this is all about the altitude hold. Okay, now by actually changing the gain and all, you can actually have a more better response. Okay, so I hope this altitude implementation part is clear to you. So the representation is same what I have covered in the theory. This is a q by daily transfer function. Okay, and this is q, this is theta, this is h, this is kq, this is q command, this is theta command, this is h command. Okay, this is theta, this is q. Okay, same, right? Theta, this is h. So the representation is same what I have covered in the theory part, right? This is p gain, this is I gain for a theta loop, this is p gain, this is I gain for a h loop. Okay, this is a rate limit, this is the position limit. Okay, you may put actuator dynamic also, tau divided by ks plus 1. Okay, actuator dynamics. Okay, later we will put the delay here, delay block, for example 40 millisecond, all signal delay, right? All right, so the representation is same. Even if you have any kind of doubt, you may ask that. Okay, so all the code I will upload in, and I will put the link in the description box. You download and play with, you will learn so many things. Okay, and maybe when you will ask some question, you will teach me as well. Okay, so that is how we should learn together, right? Okay, so we'll meet in the next class. Thank you so much.